Okay, good afternoon, everyone. So I am Keisha Rogers, and I'd like to welcome all of you who are here today with us in Pasadena, Texas, as a part of our weekly event for the Schiller Institute, as a part of our national mobilization. For those of you who are here with us for the first time, welcome. And we also have some participants listening with us online today, and we'd like to welcome them as well. And let me just get started again by introducing myself. I'm Keisha Rogers, been working with Mr. LaRouche for about 12 years now, part of the Schiller Institute and also the LaRouche Policy Committee, former candidate for U.S. Senate Congress. And I would like to start off by saying that today is a very momentous occasion and historic occasion. A lot of people may not remember what happened 44, I believe it's 44 years ago on this day, which had a very important role in terms of LaRouche's impact and what made him one of the most viable, most accurate long-term economic forecasters, which was the occasion of what he forewarned about prior of the takedown by President Richard Nixon on August 15th, 1971, of the Bretton Woods system. Now, this was the system that had been put into place by former President Franklin Roosevelt in 1944. It actually took place with a conference of about 44 nations meeting in Bretton Woods, New Hampshire on July 1st, 1944. And at that very time, President Franklin Roosevelt knew that the policies that had been orchestrated in terms of the destruction of sovereign nations, the policies orchestrated by the financial cartels, had to be put to an end. And the system of monetarism, which our nation had been fighting since the first Treasury Secretary Alexander Hamilton, against the Aaron Burr, against the factions who were the part of the operations who wanted to completely put the nation on the wrong track in terms of taking away what real wealth represented from the standpoint of productivity. What Franklin Roosevelt understood was that wealth had to be based on the conception that both George Washington, Alexander Hamilton, and our founding fathers were fighting from the standpoint of this higher principle of wealth is not based on money, but based on the productive powers of labor and of the human mind. And so when these nations met, what they did is actually develop some of the core principles in terms of how society should be organized around productive development, in terms of developing a bank for reconstruction and what later became the World Bank, or known as the World Bank, and what also became known as the IMF. People think that these things were put into place period of the last several decades, as what against what Franklin Roosevelt had intended for them to represent in terms of what the foundation of our nation was founded on. So it's very important to put that in the context for where we've seen the nation go over the past 40-odd something, 4 decades now, since Nixon took the Bretton Woods system down, which LaRouche warned only 2 years prior in a very important forecast he made around 1968, that this was going to be the oncoming collapse and the spiraling collapse of our entire financial system and our entire economy. And that the only way that we were going to bring the nation out of this catastrophe was to once again restore what Franklin Roosevelt had put into place, starting not only with the Bretton Woods system, but with his initiation of Glass-Steagall banking reorganization. Franklin Roosevelt knew that the criminals on Wall Street had to be brought down then, and we're facing the same situation today. The criminals on Wall Street have to be brought down today, and that's why it's so important that we have Glass-Steagall, the only law on the books that can actually restore a commitment to what Franklin Roosevelt had intended, that Wall Street can be brought down and that we can reorganize toward a productive economy. Now, given that context, I think we can look at the fact that we've gone a long way in terms of the rapid degeneracy of what Nixon had set into motion. And Lyndon LaRouche has been one of the sole fighters against this policy for the past 40 odd years of the IMF, the free trade policy, of the monetarist agenda that has looted the nation, and has made clear that what we've seen is a degeneracy in productivity, in real economics, and a degeneracy in culture, where the mission orientation, as we saw with John F. Kennedy, with the commitment toward the space program, as we saw with the commitment back with Franklin Roosevelt, has rapidly declined. And we're at a point right now where we are in a more dangerous situation that the nation and the world is embarking upon, as we look at particularly the last two administrations of Bush, Cheney, and Obama, to not only continue the failed policies of Nixon, who was impeached by orders of the 25th Amendment, and we'll get to that in just a second, but has continued to drive the nation into even a more detonating downward spiral. And what we have right now is we're in a very dangerous period for the existence of mankind, because as Mr. LaRouche has clearly warned, there are two factors at play here. One is that you have a puppet in the White House, Barack Obama, who has been continued to be controlled by the same British financial system and bankrupt financial system that's continuing to spiral downward, which is intended by the British Queen and Obama's puppet masters. And you see that this president, the longer he stays in office, the more dangerous the situation we find ourselves in, because Obama has been put in for one purpose only, and that is to carry out the policies of war and destruction. And I will just make the point that people should definitely refer and watch the last night by the LaRouche Political Action Committee. It's a weekly webcast done on every Friday. And the focus on this was twofold. One, that the population has to take immediate understanding of what LaRouche is warning about, and many other leading military leaders and others, about the danger of the threat of thermonuclear war. And in that discussion, he laid out, one of our members of the science team, Ben Deniston, laid out the fundamental principle of how we have evolved to levels that are 100 times than anything that was any of the bombs that were even thought about that were dropped on Hiroshima and Nagasaki in Japan in 1944. and that you have a situation now where the level of the Trident missiles, the aircraft carriers, one of these aircraft carriers can wipe out 200 major cities in a very short period of time. And he goes through the details of this, which people should really look at the fact of why is it that we have a population who sits here and accepts the insanity that we could leave Obama in office for another week, another minute, and even think that we can wait until an election in 2016. That we have, as Mr. LaRouche clearly stated in recent comments, a responsibility to fight. We have to fight now because as this financial system is detonating, you see the continued escalation toward war, the missile systems put on the border of Russia and China. It is clear that as the former general head of the DIA, Michael Flynn, has warned after he was fired from Obama, and I believe it was 2013, for exposing the crimes of the Obama administration in their actions in Syria, going to war without the express consent of Congress, the continued backing of ISIS, continued backing of the rebel forces in Syria, and what we did in Iraq as well, that the intention has been all-out commitment to war. And we have the answer to how to remove this president right at our fingertip, and it's twofold. And first thing is, one, Obama can be removed on orders of the 25th Amendment of the U.S. Constitution. And people do their studies. The report last night detailed how this amendment came to be in 1965, and this was deemed important given the fact that when you have a president who is incapable mentally or physically incapacitated and unable to carry out his duties as commander-in-chief and as president of the United States, this was actually implemented in that cause and case, and has been actually put forward more than 6 times. One of the last times it was put forward was actually under Richard Nixon, who at the time, before Nixon was approached by his Republican membership and asked to step down, there was motions toward a move of impeachment that was very clear because of the danger that Nixon represented and the crimes that he committed. And so this law is on the books, as Mr. LaRouche said, and is very clear. The second thing that is important for people to look at in terms of the moves that can be taken immediately to stop this president and his danger to the existence or the annihilation of civilization that he represents is that LaRouche has called, well, let me just say this. He has warned that Hillary Clinton must come out now and expose the lies of Obama and tell the truth about what happened in Benghazi. And let me just put this in the context that I'm sorry, I can't remember the exact date, but just a few weeks ago, Hillary Clinton, many people may know this, spoke at an event in New York. One of our members, Daniel, intervened after she finished speaking her economic forum that she was having and asked her about Glass-Steagall. She didn't respond, and she rejected the premise that we have to reinstate Glass-Steagall later. Now, a day after that intervention happened, LaRouche said then that any presidential candidate who is rejecting Glass-Steagall's reinstatement is done. Hillary Clinton's campaign is finished. And many people may have shrugged their shoulders at that, but LaRouche was right, because Hillary Clinton's campaign was finished after her rejection of Glass-Steagall, and now the onus is on her, the moral responsibility and the question of what is going to go on in the mind of Hillary Clinton. This is not about her. This is not about her emails or indictments against Hillary Clinton. This is about the fact that she holds the credible evidence that she knows that Obama made the call to her, and that the information that is clearly already out there indicates that not only was she complicit in the crimes of Obama, but that she went along with this criminality of leading to the murder of the ambassador to Benghazi, to Libya, as well as others at that time, and that what happened in terms of the pre-orchestration of these orders. So Hillary Clinton her campaign is finished, and I can tell you many leading political leaders across the United States realize this. The question is she going to do the right thing for the sake of the world and tell the truth? We can get Obama out now. Now, I think that brings us, there's a lot I can go through in terms of the details on the war escalation, but I think it's very clear. We're in a dangerous moment for mankind, and I'm not going to prolong and go through every single detail. But what I will say is, just in terms of transitioning to why we to put forth the message for today that Ian will be delivering. First of all, a lot of people may know that, and Ian will get to this, I'll just say it, I ran for 12 years, I ran for the US Congress and Senate on the platform of impeaching Obama, saving NASA. And we did this to change the subject of discussion and to put up front the truth about where this nation had to be going in terms of restoring a true commitment and vision for the nation, as President Kennedy had done. And in the course of the campaigns, the world again participated in an extraordinary event 3 years ago this weekend, which was the launching of the Curiosity mission. And this was the Curiosity rover and mission to Mars. Ian, my husband, and I had an opportunity to actually participate in that mission by going and watching the launching of the mission at the Johnson Space Center here in Houston, Texas. Around the world were watching this. This was the spirit of the unleashing of the true nature and power of human beings that goes against everything that this president represents in his commitment to war, financial collapse, austerity, and complete insanity. And we have to look at how we can reflect on what was happening, what was the importance of this mission being launched at that very time, and how it is that we have a responsibility today to make sure that we get the job done, the American people, to remove this president and all of the threat that he represents from office by orders of the 25th Amendment, and that we actually look at what we are going to bring about in terms for mankind. And this is something that the LaRouche organization and our national, international movement takes very seriously. We are now embarking on, we're not just in the midst of a political fight here. We are in the middle of a cultural warfare. And so that's why it's so important that people look at what Mr. in terms of the key driver for building a permanent renaissance, that we have to go back, we have to once again mold, as we're doing with our Manhattan Project. And people may have listened to Mr. LaRouche on recent discussions and on our Thursday calls. If you haven't been on that, I would very much encourage you to do that. And in Manhattan, that the key thing at this moment to reverse the trend of degeneracy in the culture and the population is that we're going to have to organize a permanent renaissance for mankind. And the way to do that is exactly what he has unleashed in the Manhattan Project, calling for a total revolution in commitment to scientific progress, and particularly the commitment to classical music, classical musical composition. And we have now unleashed the starting of a community chorus representing the classical musical choral principle. What LaRouche has called for is 1,500 person chorus in Manhattan, in New York, of people from all different types of walks of life, all different backgrounds, new people to singing, as well as people who have been, who are actually more skilled at singing. And this is, you think about the degeneracy, the fighting we find in the culture right now, people who are very upset by the system. You have all of these different groups that are looking for a way out. They're looking for something that can free them from this oppression. You have the Black Lives Matter groups and people of that nature that are coming out. The problem is that if we don't lead, if we don't give people a fighting chance, as far as not to allow for the rage that's in people to define who they are as human beings. Mr. LaRouche has made this clear. You think about Donald Trump. A lot of people are going toward Donald Trump as a viable candidate. That's not, this guy's, a criminal, or he represents the wrong direction for the nation. But we have to really understand what we're fighting for. And we have to give people a sense of what their human identity has to be organized around. And if you're going to look at a very horrible situation if you have a population that is driven by fear and rage. And that's why what Ian is going to discuss today in terms of the importance and the viability of the great breakthroughs, remarkable discoveries, science that we've made, from Kennedy's vision of the moon landing to what we just accomplished 3 years ago with the Curiosity mission and beyond, is extremely important. And that is what I is committed to. And that is what we as human beings have to be committed to. And that gives us a sense that we can do the impossible. When people sit there and say, yeah, right, Hillary Clinton's never going to tell the truth, or you're never going to stop World War III, people have to realize, what is this quality of human creativity and that we actually have to embody, and that we're fighting for, and we're fighting to save. So with that, let it here, and we will continue the discussion afterwards.
need my notes. Okay. So my name's Ian Overton. I've been working with LaRouche now for almost 11 years, and I'm going to talk to you today a little bit about the Mars Curiosity, the rover mission that's been on Mars now for about 3 years. But in order to kind of give you a sense of why this is such an important thing for us to be talking about in the face of nuclear war dangers and economic collapse dangers and fake candidates who don't seem to care about, don't even have a space policy. There's no space policy on the agenda in the current presidential debate. It's actually important to kind of give people a sense of why something like this is, and give you a sense of how the power that this has to actually do what Keisha was talking about. You can defeat tyrants and their machinations with optimism. Qualified optimism, not hope and change optimism, not freedom and democracy optimism, empty values, but actual real qualified things that people can be proud of and look back and say, wow, I did this, I made this happen, we made this happen, all of us made this happen. And you know, it's funny. I'm going to try my best here to coordinate between screen shares on the broadcast and showing images on the projector. I'll do my best, but forgive me if it's not always timed right. But I think one of the things that Keisha mentioned that we have to sort of get a sense of here is, if you look around you and you look at the discussion that's happening, all of it really is there's no future in it. There's a lot of past, people living in the past, people thinking about the good old days of whatever kind of, it might be the sort of like the very distant future or the other world. You know, I mean, I can't tell you how many people, there's so many people I talk to every day who, one from the religious and spiritual standpoint, tell me we're in the end times. We're looking at Revelations. We're looking at, they're not talking about other books in the Bible, right? They're not talking about Luke, for example, or doing good deeds, or 1 Corinthians 13 and really loving and caring for your neighbor, as much as they're talking about some interpretations of this is the end. And you see it in the secular world as well. You see all this talk about various government programs to kind of flip to a dictatorship overtly. You see all these talks about someone's about to crash the dollar, or they're going to crash this, and then everything's going to just kablooey. And there's also this, but there's no talk about the future. And it's been our campaign start to enunciate and make clear for people concepts of the future that are not 50 years, 100 years, 2,000 years from now, but are connected to today. Because if you don't have a pathway to get to the future, then you can have all the wonderful fantasy utopian ideas you want, but like, okay, how are you gonna feed me so that I get there? And so I think to kind of to start off with, and I'll bring this, I'm going to start narrow, and then I'm going to build out again, so that when we get back to looking at what Curiosity has actually achieved, it'll make more sense from this standpoint. In 2008, Obama was the only candidate who actually had a real space program, aside from, I think it was Newt Gingrich who was running, and he said basically privatize it all and go to Mars. But Obama actually had a space elected, and the first thing he really did with NASA was to cancel our next generation rocket and human spaceflight mission called Constellation. And he also attacked the concept of fusion energy, saying basically if we just insulated our windows better, we wouldn't need any new technologies like fusion that could do anything from help us develop new power sources and propulsion sources to new materials and new medicines. We wouldn't need that because we have better insulated windows. Of course, mass layoffs ensued in the aerospace sector, but it's not just aerospace. This is the core. Outside of the military, the aerospace engineering sector is actually the machine tool capability in the country. It's the tools that make the tools. It's the tools that make the drill presses and all the things. So up the opportunity to tour the laboratory of atmospheric and space science. This is where they make every mission that's gone out of the past Earth. From the Voyager all the horizons that went to Pluto. These people, the satellite missions that have flown to all these different planets. And that's what you're shutting down. You're shutting down the capability to imagine and create the actual physical technology that changes how we understand our relationship to the solar system and the universe. And LaRouche called for Obama 9 in like it was December. He said at this point, by attacking the basis by which it drive itself into a new paradigm, we have to get rid of this guy. And Keisha ran her campaigns for Congress on that. She mentioned that. She ran a very high-profile campaign. And then she escalated on a third campaign for U.S. Senate, took it across the state here. Now, in August of 2012, the Curiosity rover landed on Mars. And it brought a wave of optimism that was surprising to many. And let me see if I can't pull up this first picture here. These two ones here. Okay, look at those. So of the broadcast in Times Square of the first picture taken from Mars by the Curiosity lander. And this is right after it survived the landing, which in itself was a very amazing technological feat. And the crowd square watching this and why this is so important is because, I mean, first off, the Curiosity is not just a rover. What Curiosity is, it's about the size of a car. It's a ton, it weighs a ton. So it's a very large array and it's that all of the such an array of data in the world, gathering equipment and tech and sensors and so forth, that it has an effect of people being on Mars conducting experiments through the effect of what we're doing, of acting through this agency to do real scientific work on Mars that we never could have done with the previous missions in an interactive way. And quite a feat to take something several thousand miles an hour and land it at 0 miles an hour on a planet. And there's a good video, which I'm not able to stream through the day, of where you're actually looking at how that happened, called 7 Minutes of Terror, and Mars Science Laboratory puts that out, and it's a pretty good overview of all the technological feats that went into it. But this kind of optimism was the creating of a concept within the population of a shared experience of, we just made something amazing happen. And it's true. This was a major leap above any previous mission outside of Apollo and things we've done in low Earth orbit, like the International Space Station. So for the first time, the human mind has actually traveled beyond the Earth system to another body to answer fundamental scientific questions about the nature of our solar system and its development. We're able to transform our self-conception as a species by this kind of endeavor. And that's what LaRouche said this is a defeat of Obama. The Curiosity success, pulling off the landing on its own, is a defeat of what Obama had attempted to do by canceling Constellation. And it was an outpouring of real qualified optimism by the population. Now we had a situation where we were able to imagine the future. And it's being able to imagine the future that you want to create, which is what succeeds in transforming us from a fatalistic end times view of politics and science and religion and culture and society to one which is actually capable of fighting. We have to fight if we're going to win. But if we have no concept of where we want to take the world, how are you going to mobilize people to fight? Curiosity has done that. Now today, there's no discussion of this stuff in the presidential discussion or just the discussion nationally, generally. Today, we're discussing people getting killed by the police, people changing their sex from one to the other. We're discussing candidates who speak their mind, and there's a funny meme going around the internet. People say they like Donald Trump because he speaks his mind. Well, my drunk uncle speaks his mind, but obviously he shouldn't be president. Speaking your mind isn't exactly qualifying you for leadership. It's the ability the ability to unleash a qualified, we did it optimism that changes our self-conception of our, in relation to the universe we live. And the more broadly you can do that, the more qualified you are to lead. And one of the things that we really focus on in this movement, yes, we engage in political action. Yes, we engage in scientific work. Yes, we engage in cultural activities like mass public choruses and things like that. But all of these things are governed by a subsuming quality of, this is a movement, an epistemological movement, organized around filling out and developing this concept of mankind's unique ability to willfully upgrade our self-conception by transforming our relationship to the physical universe in such a way that gives us more power over it and less living at the mercy of things happening to us, which is the categorical distinction between a man or woman and an animal. Animals cannot do this. Only people can do this. And it's the culture that prides and values these things, which is the culture that's actually morally fit to survive. And cultures which value the opposite, single issue, hot button issues, things that are outside of context of that universe that we actually live in, these are the ones which are morally unfit to survive, and they're the ones which are fatalistically flawed and are the stuff of tragedies that Shakespeare and other folks who write about. So when we discuss curiosity, we discuss these what it's achieved. We're discussing how we've actually done this. We've taken a certain lid off of it, and it's so the purpose here is we actually have to remember this so that we can be transformed and go forth in our political activities or our other activities that we're engaged in more capable of creating the future. So curiosity carries 10 major scientific instruments, and I'm not going to go through every single one after the other because you wouldn't be able to keep it all in your mind. But what I'm going to do here is kind of go through some of the things that it's, and in the course of that, I'm going to talk about some of those instruments and what they allow for us to do. Let's see here. So what on 2012 in a place called Gale Crater, which is near the equator of Mars, and it's a very unique geological formation. It's a crater with a mountain inside of it, and they named it Mount Sharp. It's about 3 miles in altitude from the base of the crater, and it's about 96 miles in diameter. So it's a decent sized mountain. What it was unique about this place, they chose this place for a number of reasons, a few of which is that they thought this would be one of the places they'd actually be able to answer the question of whether or not Mars ever could once have supported life, which is the fundamental scientific mission of curiosity. And this question has been answered in the course of its first 3 years here. I'm going to show you a picture here of some of what Curiosity has been looking at. Here is this is the panorama of the landing space. This is its first image of being on Mars inside Gale Crater. And it's really funny because if you think about it this way, what you're looking at here is really just a bunch of dust and rocks. It looks pretty boring if you're not a geologist, a planetary scientist. But what we're looking at is an alluvial plain. We're looking at a place which was the silt and gravel deposits of, so let's say you have a river and it's going down a hill and it's sort of confined to being a river. And then it enters a flat area and it no longer has a river bed that it's going through. So it fans out, and that's called an alluvial plain. It's a deposit area. And all kinds of, we might think of it as a marsh in our terms. We're looking at something that would basically be a lot of deposits get put there. I think I have a map here. I'll try to show you the map. There it is. So pull that up for the web viewers. So this is what I'm talking about. So the oval here is the landing target zone that they made for Curiosity. They were trying to land it within that ellipse, and the little plus sign off center is where it actually landed. And so you can see here the alluvial fan, that's where all the deposits were moving into, and where the color here, the darker the bluish color is the lower elevation compared to the higher elevation. So it's inside the crater. it's between the mountain and the border of the crater. There's other craters that have since impacted, but that are smaller. And that's where Curiosity landed. And this is near the equator of Mars. So it, after landing using a very sophisticated system of a heat shield entering the atmosphere, deploying a very, very strong parachute that slowed it down to about 200 miles an hour, and then firing rockets to against its direction of motion to slow it down much more, and then using a sky crane to lower the rover softly onto the ground at 0 miles an hour, and then blasting off that part. It successfully did all of that by automation because it was out of contact with Earth for those minutes. So we wouldn't have known that it landed until after it had crashed or landed. That was why it's called the 7 minutes of terror. Yeah. It successfully touched down at this spot. Okay. And I already showed you kind of some of the first pictures there. I'm going to pull up another photograph here. And so here we go. So the rover, after getting all its stuff together and checking all its things, making sure everything survived and everything checks out, began to leave. It did a couple tests. It shot a couple rocks with its laser. It drove around. It has an alpha particle X-ray spectrometer, so it's looking at the spectrum of light that comes off rocks that they emit in the light that ranges that they emit when it shoots them with an X-ray laser. And that's called the APXS, or alpha particle X-ray spectrometer. It also has a hand lens imager. So it moved from this location towards an area called Yellowknife Bay. But while in the alluvial fan, it made its first critical scientific breakthrough. And this was on September 27th, 2012. The Curiosity rover found historic evidence of water on Mars by examining the area in which it first landed. So I'm going to open these three pictures here of its stream bed, and I'm going to see what I can do to, oops, did I mess that up? Try that again. Okay, try that again. Okay, there we go. And so I'll share this with the internet. Okay, there's that. All right, so here we're looking at is, so here's the alluvial fan. I was showing this image earlier. It looked at the deposits that were there, the rocks. And again, if you're a monkey on Mars, you're not able to do this. It's the ability of human beings to examine the actual sedimentary composition and determine their isotopic contents, the content of the atoms, heavier, lighter, where they came from, the fact that they didn't come from the same place or they were deposited at different time periods, that allows us to be able to say that there was in fact regular flowing water on Mars, and it was moving at about 3 feet per second, which isn't necessarily slow, it's not a trickle, at a depth somewhere between ankle and hip deep. So we're looking at something that was about maybe a varying of 6 inches to 3 feet. And it deposited a wide variety of size of grains of different kinds of minerals. And by looking at these grains and looking at their shape, their composition, and their general order, what they were able to determine is that they came from different places and they were deposited at different times, and the water, as fast as it was moving because of its ability to carry these sizes of grains of rock. And then so these grains were deposited and over time compressed into sedimentary rock. So we now know within a month and a half of Curiosity landing on Mars that Mars had flowing water. And this is not a small thing to recognize. When you think about some of the previous existential epistemology from Carl Sagan, that we are just a pale blue dot, and we're alone in a big empty universe. And there ain't nothing else like that out there. And now we discover that he was wrong in a really big way. And he's wrong in another other ways. But I don't have time to get into what the Kepler mission has done, which is just simply fascinating, and that's a whole other discussion on its own. But what we're looking at here is evidence of a real different understanding of the history of the development of our solar system. At some point, Mars was warm enough, it had an atmosphere that was dense enough to maintain flowing water. But that's not all, and we'll get into that. So, okay, so what Curiosity then went to proceed to do is it proceeded to move to its first area of study, which was called Yellowknife Bay. And in Yellowknife Bay, one of the reasons that this area was targeted by the scientists in the Mars Science Laboratory, JPL, was for its confluence of different geological features. Now, I just have to specify, I'm not a geologist. To me, this looks like a bunch of rocks. But what's important about this is that from what I've been able to glean by reading the press releases and just being generally a literate person, is that different rocks have different hardnesses, and they decompose, and they're eroded by if you have a rock and it's repeatedly struck by a certain dust or water or something, it will erode, and other rocks that are around it will erode faster or slower based upon them being harder or softer. And that's how you get all sorts of unique formations. If anyone ever had a chance to go to Colorado or Turkey, you'll see certain rock formations like the Garden of the Gods or the Love, whatever it's called, field or something like that. And you'll see these rock formations that stick out of the ground at all kinds of weird shapes. It's or the mesas in Southwest United States. It's the same kind of thing. So what we're looking at here in Yellowknife Bay is the confluence of different kinds of sediments. So A, B, and C show us these things. Now, I'm not going to get into all the details of that, but I want to point out that the next major discovery that occurred was in this area. And that discovery was heralded up as just as important as the landing itself, and it's this. This is the first borehole of a rock on Mars. The one on the right is a test bore, and then the one in the middle is the actual borehole. And this act of boring a 2.5 inch deep hole that was 1 5/8 inches in diameter, was considered to be as important as the landing of Curiosity itself on Mars to begin with. And I already went through, that was a pretty amazing feat, right? We landed a car with full of scientific instruments where a coordinated set of minds is engaging in real scientific work on Mars through the mediation of this machine. This 2.5-inch hole is just as important as that. Why would someone say that?
Right, please tell us. Quick, quick.
Oh, the tension. On March 12th, 2013, it was announced that we've now discovered that Mars is gray.
Is what?
Gray.
Oh, it's not red.
Well, today it's red. But previous Mars had mudstones, had mud. It had a rich environment that was not rusty and dusty, but wet, providing of an energy gradient of the sort that many microbes on Earth. And this borehole that you're looking at is a borehole into a mudstone. What we just drilled into here was an ancient lake bed on Mars. It was all the previous studies of Martian chemistry and things that are available to us indicate a Mars which is highly oxidated. Oxygen being a very corrosive element. It was very salty and very acidic. These three qualities would make life. This borehole revealed is that actually Mars used to be not super saline, not super acidic, and warm and wet, effectively luscious for microbes. This answered the fundamental scientific intention of Curiosity within the first 6 months of its landing. We now have a totally different view of our solar system. Earth was not the only planet capable of supporting life. Later on, they were able to sort of date some of these rocks. They dated a rock they called Cumberland, which was revealed in late December of 2013 to be, by measuring the rate at which potassium decayed into argon and comparing the known ages of moon craters from Apollo and their depth with Mars craters, they dated the rock at being almost 5 billion years old, and has been exposed to the galactic radiation, which has caused additional buildup of gas and so forth over the last 60 to 80 million years. The point of that information is to say that what they're looking at is that the formation of this material happened at a time when on Earth there was already rich life in the form of very simple life. Things without skeletons, microbes, amoebas, that kind of stuff. Which begs the question, well, okay, if there was life on Earth with the same environment effectively on Mars, why would there not be on Mars at the same time? Especially given what we already might think about in terms of some of the way that life transports itself throughout the solar system and the universe through things like comets and so forth. There's definitely a lot of good reasons to consider that life actually might have cosmic carriers like comets to help travel around. So, you know, it's an honest question. Why should we? The real question here is not, did Mars ever have life, but really, could Mars not have had life on it? So just for fun, the next thing I'm going to show you is on June 19th, 2013, Curiosity sent home the biggest picture we've ever had. It's over 1 billion pixels in size. And let me pull that up here. Just a moment while I do that. Screen share. Okay. So this is the billion pixel view. Wait a minute. That's the. Wait a minute. I'm sharing the wrong thing. Hold on. Okay. Let me. Oh, there we go. Turn off full screen. Let's try it again. Okay. Share that, and then go to that. Okay. So this is the billion pixel view of Mars. It's 1 billion pixels. It's enormous. And what you can do. Yeah, I know. So we're gonna go through and we're gonna zoom in on a couple of these things. So here's a rock for scale. This rock is about, oops, it's about 17 inches. Is this thing going to tell me what it is? Let's try it again. I think it's because I moved. So over here, this is the landing site, and let's go back to the rock for scale. And okay, 17 inches by 10.5 inches, about the size of 2 side. And it's pretty good resolution. I mean, we're looking at something that looks like we're standing there on Mars looking at it. Here's Mount Sharp off in the distance. 3 Mile High mountain. Over here is the landing site. You can see some tire treads there. Here is a rock that has been zapped with a laser. The chemistry camera. Here's a rover's tread mark using the Morse code to, once it loads. Here's a bird-shaped rock. This is another one of these things. Some people talk about how of ancient civilizations on Mars because nature doesn't make square lines or things like that. But here's one example of how erosion works. If you were to look at this from a different perspective, it probably wouldn't look like a bird. Some things like foreshortening.
Things like what?
Foreshortening, like when you look at something head on.
Good afternoon. We have a little after back to school activity planned. If you'd like to come in.
And that's why we hold meetings in libraries. So anyway, so this is just, I think the point here is to the sense of the kind of like the high definition idea of what we're dealing with in terms of being able to actually have the mind of a human being operating through the technology to do the same kind of experiments it could do if it was actually there in person. including looking at stuff, which is simple observation is a part of that. We have the lasers to be able to look at. So what some of the things that curiosity does is that it it has the ability to scoop up soil, funnel it into an oven, heat it into a plasma, and then look at the chemical and isotopic contents of the soil by the light that the plasma emits. It has the ability to do the same thing with a drill. So it drills into a rock, it can brush the rock off, it can drill into it, and it can suck the dust up through the tube into a sifter and then sift it and heat it and analyze it. It has the ability to look at hydrogen in the soil directly below it, and the hydrogen is basically an investigation of water. And what they found is actually the soil of Mars is very similar to soil in Hawaii, in the sense that it's highly basaltic, which means it is volcanic in origin. And the dustiness of it, while it is very dry, it actually has a very high water content, what they said around 2% water, which is much, much higher than they thought. It's high in chlorine-based salts called perchlorates, and then it has a lot of the other minerals you might expect in a crustal environment, olivine and other things like that, jarosites and things. But what they found is that in this area that they're looking at specifically, there's also nitrates. Now, when we think of nitrates, we think about, okay, nitrogen is a organic compound. It's an organic element. Nitrogen, oxygen, carbon, and hydrogen are considered to be organics in the sense that they're very common elements that form the basis of a huge variety of molecules, which are this, what you call the building blocks of life. In other words, organic matter, as in living matter, uses and is very much involved with and dependent upon these four elements in its ability to do what it does. And one of the things that over the course of, I'm skipping through a lot here in terms of all of its different drillings and looking at things and different rocks and so forth that Curiosity has done. But one of the things that it discovered in December of last year, just a few 9 months ago, its surface atmosphere on Mars instrument detected the first evidence of real organic compounds, and then in February it discovered biologically useful nitrates. Now, nitrogen on its own is inert. It binds with itself in a very, very hard to separate manner, and so it's not very useful to living matter. But when it's oxygen, it becomes a nitrate and is then considered to be, as we call it, fixing it. So you have these nitrogen fixing bacteria that live on the roots of things like peanut plants and other plants that interface with bacteria to allow the plant to use the nitrogen in its uses, in its life. And it changes from simple nitrogen to a nitrate in that process. Being fixed is what the term is in horticulture and so forth. Well, they found biologically useful nitrates of the samples that were taken in Yellowknife Bay. When they were doing
Plant life?
No, they didn't find plant life. They found the minerals that plants would love to eat. Were plants ever there? Or bacteria would love to be involved with this. So the point is that everything life could want did exist on Mars. The only thing we haven't found so far are fossils, basically. We've also discovered quite a bit in terms of, well, we don't yet know what caused Mars to lose its upper atmosphere. We know that it has lost a lot of its atmosphere, that its atmosphere at one point was thicker and warmer than it is now. But they haven't answered the question yet of what caused that. But of last year in 2014, the orbiter called the Mars Atmospheric and Volatile Evolution, or MAVEN orbiter, arrived at Mars, and that's the main subject of its scientific investigation, is to actually answer the question of what happened to Mars's atmosphere over evolutionary time, over geologic time. Did it, what caused it to become so thin? So, where is Curiosity now? Let's see here. The most recent image of it. Let's see. Okay, I can share this picture. So one of the things I've not done is given you all the names of all the little things that they've called stuff, but they named the landing site after Ray Bradbury. Then they went to Yellowknife Bay, where they made the boreholes and discovered the evidence of water and the mudstones. And they've passed through a lot of other different places, different scientific waypoints. And they did a lot, for the last around November of last year. Well, around August 15th of last year, the rover arrived at the base of Mount Sharp, where they're calling that Pahrump Hills, kind of the foothills of the mountain. And for a good 6 to 8 months prior to that, it really just focused on driving. So it drove from Yellowknife Bay, made a couple science stops for measuring and scooping of soils, and then it just pretty much focused on driving. One of the things that's happened a lot in the course of all this is just dealing with the very intense radiative environment of Mars. They talk about an average chest X-ray is 0.062 millisieverts of radiation, and the average daily dose of radiation is like 0.94 millisieverts of radiation. And I can't give you the relationship of a millisievert to other things to make that sound more, other than what you get from a chest X-ray is minuscule compared to the daily amount that's being exposed on Mars, by the vast majority of which is actually cosmic in nature, galactic cosmic rays, rather than stuff coming from the sun. Electron particle events, things like that. Solar, the kind of stuff like the Carrington event, that kind of stuff, or stuff like what you get that causes the auroras. That's not a big factor in terms of adding radiation to the Curiosity's mission, but it's been getting the vast majority of this coming from other stars through the mediation of the sun into our solar system from the other parts of the galaxy. And so there's actually been quite a number of electrical shorts and other things that's had to deal with, computer backup failures, things like that, having to switch from A to B, and it has a redundant computer A and computer B to prevent things from going south. But that's the nature of the game. So they're actually trying to navigate up some of these hills. Their wheels were a little damaged. They're able to notice all of these things and deal with them, and basically repair their science vehicle from Earth in situ. So it's not like you're just driving this car and, when you're driving a car, obviously you're thinking about all kinds of things. You're listening to the engine, you're listening to things rattle around, you're looking at all your gears, you're looking at all your, not your gears, you're looking at your odometer, your speedometer, your tachometer, depending on what you got. You're listening to all the, you're involved in the environment that you're driving through. If anyone has ever been off-roading, that's what they're doing here. There's no roads on Mars. There is one trail that they just blazed, right? So,
Say the distance, Ian, that's been covered so far on its travel?
let's see here. Yes, there's a scale on the map. It arrived at Kimberly from the landing site. That's 3.8 miles. And then I don't think I wrote down the total mileage, but
So it's at Bradbury Landing? or-
that's where it landed.
That's where it landed. Now it's in.
Now it's at Pahrump Hills, and it's at the
We don't know how many miles.
and from Bradbury to Kimberly, which is looks like about 2/3 to 3/4 of the way. That's
Ah,
right. So it's traveled maybe another mile or so. Where it is now is at the base of Mount Sharp. It's starting to climb up the mountain. It has, this is the latest picture. Let me just pull this one up. This is the latest picture. And as it's climbing Mount Sharp, what it's discovering, okay, so when it being a mountain, its sides are reflecting a large number of different geological times. So they're finding that as they go higher on the mountain, they'll enter a different period, and they discovered that it wasn't like there was always water in this lake and then it just dried up and that was it. It was dry, wet, dry, wet. Sometimes it dried up very quickly and there's a very sharp boundary. Sometimes it's a very smooth gradient. And this rock formation here is unlike any they've seen before. It's very high in silicates, which most of Mars is not in terms of their experience.
Very high in what?
Silica.
that's sand, isn't it?
It's glass basically in a sense.
Yeah.
One of the other things that they've found through just having a weather station on the whole deal here is that it's very likely that a briny dew condenses at the surface across Mars every night and then evaporates in the morning. So the perchlorates, which are these chlorine salts, they lower the freezing temperature of water and they're very effective at condensing water onto it. And the dust that they've looked at, they've said is a good global sample of the dust on Mars. So Mars does get global dust storms. It also gets regional ones. And by their analysis, we do have a global distribution of these perchlorate, the dust that coats everything on Mars. So it's very likely that we do have a morning dew or an overnight condensate of water in the top layer of soil every night, which does have important aspects for things like if human beings ever do go to Mars, is there a viable water source? So, okay, so that's what they're talking about. They're saying the next step, they're going to send another mission to Mars. There's a couple that are. One is to do a deep drill and go deeper down into the crust. Another is to gather rocks for return to Earth. And then there's talk about a eventual human mission to Mars in the 2030s decade. Now, okay, so this brings me back to some of my original point, which is the change in our understanding of ourselves in relationship to the universe. And I haven't touched on a lot of other missions that are going on at the same time. I mean, the Kepler mission looking at exoplanets around other stars, for example, is a critical mission in terms of doing this. But the point that I'm trying to get at is by discovering that Mars is not just a red planet, but it was at one point a gray planet. We have eliminated a certain limitation in our ability as people, as human beings, conceptualize where we come from and where we're going and what we can do about it. And this is a quality which is exceptionally dangerous to the oligarchy. A grouping of people that would rather have the rest of the planet operating as debtless is going to have to kill the inspiration that comes from really discovering something new about the place you live in that changes everything you thought of to be the case. And that's, I think, a big reason why this sort of discussion is not happening in the presidential elections. Why you're seeing instead a bunch of banal subjects, all kinds of stuff. Because if more people were actually captured the awesomeness that even in our own solar system there is the potential for life beyond Earth, or at least at one point there was, and maybe if we were to take a much more aggressive approach to biospheric engineering, there could be again. I mean, we no longer have to live at the mercy of things that happen to us. One of the other major things that's really critical to look at is this question of how the galaxy interacts with the solar system. If we understand Mars to dry up and lose its moisture and lose its atmosphere, we can do the same thing to California, and exactly, and we can. I mean, what has already been done in terms of a number of countries around the planet, in Oman, where they realized that the clouds that are rain clouds, the lower level cumulus clouds, they condense because galactic radiation enters the atmosphere and ionizes the sulfuric acid and other volatiles in the atmosphere at that level, and then the water droplets condense onto those and become clouds, which then falls as rain. So you have, and this process is mediated by the sun. A more active, more magnetically active sun disrupts more cosmic rays. And by doing the same thing from the ground up, by building these towers that direct, I think it's electrons, into the atmosphere, which ionize the same gases and then cause the water to condense on them and then fall as rain, we're able to pick up where nature left off and increase rainfall in areas that desperately need it by noticeable percentages. It's the ability of human beings to transform their relationship to as broad as a reach of the universe as possible, to change our self-conception as a species, for us to do things like avoid extinction, whether it's by our own hands and the folly of capitulating morally to incompetent and egotistical leadership, self-serving leadership, or by short-sightedness in the face of natural disasters like asteroids, meteor, comets, or solar proton events, or long-term shifts in the galactic climate. And I think that's actually when we start to say, okay, we're going to solve these problems, and we start to articulate a vision of the future, and we start to actually build missions like the Curiosity mission that allow for us to answer these questions. That's where to go back to the optimism, that's where you actually see a mass outpouring of the population. And what you see from the population is that they love this stuff much more than who got a sex change. Because it's true. I mean, the people here are captivated in a way where it's, think about the last time that you were really inspired by something and what happened to you. You came away with energy, more life in you. You were imagining where you wanted to go and what you wanted to do. And we did that as a country and a planet when we landed safely to Earth. We unleashed this despite the opposition of a greeny president who said no to fusion and no to human spaceflight. Science triumphed over Obama and that clique, and they've done their best to eliminate that memory from the discussion, and we are bringing it back. And we're bringing it back through these meetings that we're having all over the country. We're doing this, of course, here in Texas. We're doing this in, of course, Manhattan, where we're having the best response because there's an actual intellectual life there in that part of the country. I think my computer screen froze, but anyway, so the point here is, I think, that we can, but we have to fight. But we don't just fight against a problem and say we don't like that problem. We fight because we have a concept of the future that we're going to create, and we're taking, and that is our weapon. So I think my computer froze, but that's all I had to say. Yeah, I'll take some questions.
Can you review again the significance of the boreholes? They bored, how deep are it was the boring, and what is it showing?
Yeah, so the borehole was 2.5 inches
Wide.
deep.
Oh, deep. I was thinking that was the diameter. Okay.
No, the diameter was 1 5/8.
Okay.
So these are not big. It's about as big as a bottle cap. Maybe a little bit. Well, it's a little bit 2.5 inches, so it's about 2 or 3 bottle caps wide. But it's it's really not a deep hole.
Okay.
And what it was able to do is able to say the content of the dust that was bored out of this rock it used to be mud. It's a mudstone. So you've heard of sandstone, you've heard of limestone. This is mudstone. If you take mud, which is a combination generally of silt, which is and rock, what you're looking at, that being compressed into rock, right? And it contained, its chemical composition was not overly salty, not overly acidic. So its pH was more or less neutral, about 7, right? Its pH was balanced, right? So-called. And that was everything that you would need to be favorable for life to flourish. And that's the significance of that.
Okay. Well, what are we saying about the source of this, and what kind of water? I mean, do we know water? Do they have a certain kind of chemical in it, or what?
I don't think it was filtered water. Yeah. yeah, I mean, from what we do know about the dust and the things that the a lot of the stuff that's on the surface has been when the dust blows around Mars, it's affected and changed by the environment being oh good, I think it's finally responding now, being impinged by the galactic radiation that's hitting it all the time. So there is active changing chemistry on Mars. It's not just like a dead planet. Now
we're saying the source of water is from the atmosphere or from the internal?
I couldn't answer that question. Water came from originally. That is a my knowledge.
Now we've had landed on Mars, and actually it was quite remarkable how they didn't do all the experimentation and testing. But how many missions to Mars have we had now?
Well, there was the original Voyagers, which there's the Viking mission, which also passed by it. Landed, yeah, the Viking lander, and then there was Spirit and Opportunity, and one of those went kaput, right, I think, and the other one's still kicking around doing stuff 10 years later.
One of Mars
Opportunity, yeah, still kicking around. So, and then I don't know. In the last few months, India's Mars observation monitor, or whatever it's called, the MOM, arrived to study Mars, and so it's not a lander floating around. Maven arrived a few months ago. It's another orbiter that we sent. And then, of course, Curiosity.
The previous rovers depended on solar panels. Curiosity has a.
It's got a nuclear plutonium nuclear engine.
That's a big difference. Right.
It is a big difference.
Yeah. And all the photography, amazing photos we had for Curiosity, those were from what then?
Those are from the other two rovers.
The rovers.
Yeah. And then we do decent resolution from some of the orbiters. I mean, it's nothing compared to what we have today. Yeah.
And how long did it take Curiosity to run?
Oh, I don't know. I think it was, several months, 9 months.
That's short, yeah.
So I'm going to stop the broadcast. If people have questions, I'll submit them, hang out on the YouTube page, and I'll get back. Likewise, if we want to break into informal discussion here, we can. We'll be back next week with another amazing subject. Now, oh yeah, music. Okay, cool. Yeah, we're going to be talking about awesomeness and music. So that's great. All right, see you all later.